Today's lesson looks at slope in a particular way as rise over run. I think we all have some experience um, with steepness. So if I ask you the question, what makes a good water slide? And what makes a good water slide is you go really fast when you go down it. And in order to go really fast on a water slide, the water slide needs to be steep. If I said, what makes a good wheelchair ramp? Well, a wheelchair ramp, you want to be in control. You don't want to be going very fast. So a good wheelchair ramp is not very steep. And this idea of steepness has a mathematical name, and the mathematical name for steepness is called slope, one interpretation. So here's what slope is in with respect to this idea of steepness. Slope is the ratio that compares the change in vertical distance to the change in horizontal distance. So with the water slide, you're going to have a much bigger drop compared to um, uh, the width of the water slide, say. And on a wheelchair ramp, you're not going to have a very big drop compared to the width of the wheelchair ramp. So if I drew, these pictures aren't scale, but here might be my vertical drop, and there's the width of the water slide, and we'd all agree, wow, that's pretty steep. For a wheelchair ramp, you're not going to have a very big drop compared to this long width, and we'd all agree that that's not very steep. So this is this idea of slope as a measure of steepness. So slope can be expressed as a formula, and the formula, or as a ratio that we talked about last day, but as a fraction. So a change in the vertical distance over versus compared to, however you want to say it, the change in the horizontal distance. And the change in the vertical distance and the change in the horizontal distance has another name, and it's rise over run. So rise, think of, rise like an elevator, and run, think of a dog run. And the symbol for slope is lowercase m. So slope is equal to change in the vertical distance over the change in the horizontal distance. Easier way to say that is rise over run, and the letter used for slope is lowercase m. So here's an example of just calculating the slope, giving a number to this steepness. Calculate the slope of a staircase that has a rise of 12 centimeters and a run of 8 centimeters. Well, slope is equal to the rise over the run. So that's the slope of this staircase. And again, just as with ratios and proportions, sometimes it's easier to simplify them and then deal with things when they're simplified fraction. So both 12 and 8 have a common factor of 4, and we can express slope in a simpler way. So slope can be expressed as a fraction, as the example I've shown above, or a decimal. But one of the problems with a decimal is, given that we don't have something compared to something, like a top number compared to a bottom number, we lose our understanding of a ratio. So sometimes most people like decimals better than fractions, but here's an example of fraction actually uh, tells you a lot more and helps you understand a lot more. So when we calculate slope or determine slope, the bigger the number, the steeper the slope. And the smaller the number, the less steep the slope. So we have a formula for calculating how steep something is, and that formula spits out a number, and that's about it for right now. So, so what knowing slope allows us to do is to answer some questions we might have. So here's an example of one of those occasions. The slope of a hill is 7/20. So the vertical change is 7 meters or whatever the units are given for every 20 units of horizontal change. And what the question is asking is, what is the rise of this slope of this? What is the rise of this hill if the run is 100 meters? So if we kind of just did a quick little sketch, here's what this would say. My hill goes up 7 for every 20 across, and that's what it might look like. And we're going to assume that the hill has a constant slope, meaning it doesn't get steeper, it maintains this steepness. So basically the question is, if we have this this horizontal distance of 100 meters, we want to know how much is that going to go up over the 100 meters. So obviously it has to be bigger than 7 because 100 is bigger than 20. So the way we can do that is we can set up our slope ratio as rise over run, and we know 7/20 is going to equal the vertical distance, I'll call it V for vertical distance, over this horizontal distance. And in the last unit we looked at this relationship that would help us determine, help us solve an equation like this, a proportion, and we we had the idea of you don't have to solve it as an equation if you don't want to, you just have to find a nice relationship. And again, there's a really nice relationship going horizontally. And 20 times 5 is 100. And in order to maintain our equality, we have to, what we do to the bottom, we do to the top. And in doing that, our vertical distance that this hill would go up over 100 meters would be 35 meters if it maintained the same steepness and slope, and we're going to assume it did. So the things we learned last lesson allow us to answer questions around our new formula, this slope formula, and around the idea of steepness. One last example. The slope of a slide in a playground is 17/10. So there's a vertical change of 17 for every horizontal change of 10. If the maximum slope allowed for this slide is a horizontal distance of 1.5 meters, horizontal would be the run, how high will the slide be? What is the rise? So again, we're going to use that word slope to set up our proportion, and we are told that the slope is 17/10, and we are given in this particular example, the horizontal distance is 1.5, and what we want to find is the vertical distance. Now, the units here are in meters. And if we looked at this proportion, it might be difficult to find a nice relationship that would help us solve this problem easy. But if we change this to centimeters, this calculation is going to be easier. So easier to convert to centimeters. And if we do that, as long as our units are the same, we can do things like this. 17/10 is equal to the vertical over 150. So there are 100 centimeters in a meter. We're going to multiply 1.5 times 100. And then the really nice thing is, as soon as we do that, we see this nice relationship. 10 times 15 is 150. Therefore, that same relationship has to be on the top, and then we can figure out V. And when we figure out V, V is equal to 17 times 50, which is 2 years, and that is equal to 2.55 meters.